Hello and welcome to this Dr. Ross video on comparing coefficients of surds and non-surds to determine values of variables. Let's read the question. Given that 1 plus a root 5 all squared is equal to 46 plus b root 5, where a and b are positive integers, find the value of a and the value of b. Now before we approach this specific question, there's just one thing that's worth mentioning. If I had, say, a plus b root 5 is equal to 3 plus 4 root 5, then on each side of the equation, the non-surds must match. Now this is a non-surd because it doesn't have a square root in it. That's a non-surd. So these would have to match. So the a would have to be equal to 3. And the surd terms have to match as well. So if we've got a root 5 term on the left-hand side of the equation, and we've got this root 5 term on the right-hand side of the equation, then they have to match. So the b must equal to 4. So b must be equal to 4. So the a is equal to 3, and the b would have to be equal to 4. The proof of this is actually quite complicated. It relies on the fact that surds are irrational, but I'm not going to prove it in this video for the sake of time. Now, with this question here, we need to compare the left and right. Now, we've got this bracket squared at the moment. So you might need to expand this bracket out first so that you can compare the terms on the left and the right hand side. So let's do that first. We're going to do 1 plus a root 5 squared, and to square it you just times it by itself. So we've got the 1 times the 1, which is 1. We've got the 1 times a root 5, which is a root 5. We've got the a root 5 times the 1, which is a root 5. And we've got the a root 5 times the a root 5. Well, root 5 times root 5 is 5. The a times the a is a squared, so it's 5a squared. If I just simplify that a bit, let's do the non-surd terms first. So we've got the 1 and the 5a squared, they're the non-surd terms. And then let's look at the surd terms. We've got a lots of root 5 plus another a lots of root 5 plus another a lots of root 5. That's 2a lots of root 5. Now, we've got this, and we can now compare it to the 46 plus b root 5 we have on the right-hand side of the equation. So this has got to match the 46 plus b root 5 on the right-hand side of the equation. Now, as I said over here, the non-surds have to match and the surds have to match. So, on the left-hand side of the equation, what are the non-surds? Well, the 1 plus 5a squared is the non-surd, and the 46 on the right-hand side is the non-surd that doesn't have the surd in it, the root 5. So if we match these, we can say that 1 plus 5a squared is equal to 46. Now if we solve this equation, well, a is being squared, it's times by 5, then you're adding 1 to get 46. Let's minus that 1 from both sides of the equation. So then that gives us 5a squared equals 45. Then a is being squared, then it's being multiplied by 5, so we need to divide both sides by 5 to give you a squared equals 9. And then if we square root both sides, a is equal to, well, it could be 3 or minus 3. However, it tells you that a and b are positive integers, so a is just 3. Now we've worked out a, we now need to work out the b over here. But we can also match the surdy terms as well, the surd terms. So the 2a root 5 has to match the b root 5. So the root 5 is already the same, so that 2a has to match the b. So we know that 2a is equal to b, but we know that a is 3. So therefore 2a, 2 times 3 is 6, and therefore we know that b is equal to 6. So now we've worked it out, we know that a is 3, and we know that b is 6, and we've got the final answer.